to noon class. All right, so welcome to class. Today we're basically going to continue what we've been talking about. One thing I did was, up until this point, I for the course GitHub, one of the things that I did was modify all of the classes so that I put all of this year's stuff in the root directory, and anything that wasn't this year's stuff I put in this folder called archive. So if you want to go back and look at older examples or whatnot, you can. But now there isn't anything in each folder up to this point that is not from this year. So today we don't have much because we don't have any examples yet. So the only thing in the directory is the data that I'm going to use for this class period and the README, which the README also shows up here. Okay. All right, so I don't know why these, sorry, I don't know why these should all be on their own separate line. I'll fix that. That's what we're going to work through today. We're going to practice a little bit more and learn a little bit more about making script tools. We're going to learn about a couple of tools that are kind of unique to script tools, and we're going to learn about the kind of some best practices when you make a script tool. And so the first thing I'm going to do is download the data from today. And then today's lab is actually going to be, because we're kind of building up to this point anyway, today's lab is actually going to be a little over half of your grade for the midterm. So the midterm's always been on the syllabus as probably a take-home, and I had a number of people that were concerned earlier in the semester as to whether or not it was definitely going to be a take-home because they were going to be gone. It wasn't just one student here or on the coast. There were people from both locations that asked me to determine whether or not it was going to be take-home. So I ended up not traveling. So I'm going to be here, but we still won't officially meet. I'll be here. If anybody has a question, I can answer it. But today we're going to give the exam, and the exam will be due the week we get back from spring break. So it's actually almost 3 weeks that it's due. So we've got today's lab will be the midterm, and so instead of working all the way through it, or at least even most of the way through it, we'll only introduce it, and I'll work through a different problem. And the exam has a lot of very, very many similarities to the work that we've been doing for the last 2 weeks in ArcPy. So one thing that I want to, well, maybe I'll cover this better when we get to the actual exam, but one thing I want to make clear is that the problem that we have here, this problem, if you have questions about how to do it in a GIS, that's a question that you can ask me, and I'll help you think through it. Okay, so I'm not going to provide as much help on how to actually code it up, but if you have a question as to what you need to do, let me know. It is a pretty straightforward problem, and that's the part that we are going to cover later today is how to work through it. And then we'll let you code it up, but it's very similar to solutions that we've already coded. Now there will be a written portion of the exam, but that'll still be take-home. So you can use your book to answer the questions, but and that one will have some Python syntax, like what does this do, what does that do, and you can use any resources at your disposal. All right. Okay, we'll cover the exam later, so if you have questions about that. I don't know how long that took to download, but I kind of got off on that subject a little early because I was waiting for that to download. It probably downloaded in 2 seconds, though. Who knows? So I'm going to put this in CTemp, and I'm going to make a new folder called SBA Lab, I guess. So I'm going to paste the zip file in there. Oh, I didn't mean to do that. I meant to take, oh, I did. Okay. Yeah, I meant to extract the contents of the zip file. So now I've got a GDB in CTemp SPA Lab, or wherever you want it. I'm going to get a new folder here. Just going to open up. So the example that we're going to work with today in class is some more census data. This is CTemp SPA, but SPA Lab. So this is what we're going to use today in class. This is the data for your lab / coding part of exam 1. So that's this part right here. That's this data. And these two data are in different projections. So I'm going to open up first this block group _HS. Not exactly sure what HS stands for in this case. Forgot. But this data is in Mississippi Transverse Mercator. So the units are all in meters. And that's different than the other data, which is in Minnesota. We'll talk about that later. Okay, so these are census block groups. This is the second smallest level of aggregation that the census has. And the size of a census block group is just determined such that they contain roughly the same amount of people in each census block group. All right. So I have the attributes here. The attributes that you see here that I'm concerned with are we have different age groups. Okay, we have different age groups, and we have different race, white, black. We also have the population. This population column is the projected population in 2017. They don't take a census every year, but they do project the population out each year. They take a sample and they try to figure out what the population is. But they take a census every 10 years, so this is the population in 2010. So they projected this area grew, whereas they projected this area right here shrank. In fact, as a whole, I've actually looked at some of the trends here. Marion County is, for the most part, losing population, whereas Lamar and Forest County are gaining population. But anyway, this is on the edge of Marion County over there. Okay, so we're going to use this data in our example today to teach a few more concepts, and that we've kind of gone over, but we haven't really solidified. I kind of said, oh yeah, there's these other things. So we're talking about building script tools, but taking it a little bit further. So a few of the concepts that I want to talk about, maybe I'll talk about this one first because it doesn't involve doing any Python coding. But one of the concepts I want to talk about is oftentimes when you build a script tool, it's going to be different than just creating a model that you might run. Because the purpose of a script tool is really to be able to share with somebody else and say, I've created this tool, and I want you to be able to run it and make a decision. Or maybe somebody, maybe it's actually something that you do at work, and your boss actually says, hey, I want to be able to run this model, but I want to be able to vary these different parameters each time it runs. Can you do that for me? And you say, yeah, I can make a script tool for you. Okay? So we did mention last week that script tools often have data that they're dependent on. So it's kind of part of the data that's cooked into the tool. In this case, it would be like this data here. Okay? So we might be wanting to make a tool that looks at population. Okay? And so that data gets stored along with the tool and used every time in the tool. Now, the first thing that I want to talk about is oftentimes there's some process that's part of a general model, a GIS model, that gets run every time you execute the tool. For example, if you have two data sets and you always want to do an intersect with those two data sets before you do any analysis, and there's no part of the model input that is dependent or that changes when you do that overlay, that intersect overlay, don't make that part of your model. Don't write a script tool that does that. Because all you're doing is inserting another step that has to be run every time the model is run. Okay? Now, where might that be a problem? You think about, what if the data is changing a lot over time, right? Okay? Well, then if the data is changing with such frequency that you do actually need to run it beforehand, that's fine. But if the data is changing once a year, you could write a separate script that just says update data, and that would do the overlay, even if it's updating once a month, or even if it's more frequently. If you can predict that, you can write a separate script tool that will prepare the data for the tool. And this gets really important in some settings. We don't cover this in this class, but we talk a little bit about it in the web, for the web mapping course. We talk about it. You can take one of these models that we've created, these models that we script up or that we create through Model Builder, and you could publish the model along with the data so that people can interact with it on the internet. And most of the time, people don't love interacting with things on the internet. For some reason, our tolerance for the amount of time that it takes for something to happen on the internet is lower than in other situations, right? I mean, I don't know if that's universal, but I think most people, if you want to make your tool, if you're publishing it for the internet, work as quickly as possible. Because just because it's published for the internet doesn't make it magically faster. In fact, it makes it a little teeny bit slower. If your tool takes 5-6 seconds to run in real life, it'll take it slightly longer to run if you publish it for the internet. But if you could take out an extra intersect, make it so that never runs, or you run it on like I said, a yearly basis, that would be helpful. So always, once you come up with the model, the scenario you're going to do, the first step is to ask, is there any pre-processing that can be done? Is there anything that we can do to reduce our data so that we don't have to include this in the model? Okay. So, to practice that, I'm gonna go over what we want to do with this model. So, in our practice scenario here, we've got all these census groups. And what we want to do, and this is something that we haven't covered yet, so this is another topic that we're going to discuss. We want the user to interactively be able to select a region, interactively. So that's something that does get done on, it's kind of like a web app. It would be a step toward creating this to work on the web. Okay? We want them to be interactively able to draw a polygon. And then we want to take that polygon and ask the user, not ask the user, but let the user decide if they want to buffer that polygon out further. Okay? So the first thing is that they're going to be able to interactively select. So we're going to learn about interactively, basically creating interactive shapes. Okay, that's called a feature set, or an interactive table is called a record set. But anyway. So we're going to learn about that. And then we want to be able to find the population in that area. And we're going to use the formula that we did 2 labs ago to do that. So basically, we're going to calculate the area of all of these census block groups, and then we're going to generate that polygon, do an intersect, and then find out the new areas, calculate the proportion that should be in the new intersect, and then we need to find a way to report to the user the final value, the total inside that interactively drawn polygon. Okay. All right, so we're going to have to do a little bit of information. There'll be a little bit of things to do that. Basically, we need to do a dissolve, and then we'll do that. Okay, so let's think about that problem first. Okay, think back to overlaying the census tracts. Those were larger things, with the watersheds that we did. Now that's been like 2 meetings ago. Not this meeting, but the meeting before that. Okay, we did it in that meeting. What was the very first step? You remember? What did we do? How did we modify the census tracts? Everybody go back to their code. What was the first thing that we did? We added a field, and what did we do with that field? The original area, exactly. We added a field and we made it equal to the original area. Is that something that we might do multiple times? This model is basically the same, except for we're only dealing with one other polygon. Yeah, that's something that we're going to do every time. So it wouldn't make a whole lot of sense to build that into our model. In fact, I put it in there to get you thinking about the process and practicing running more tools. But even if we went back to last week's, it would be great to take it out and to just pre-calculate it if we were going to actually do this for real life. Okay? So let's do that. Let's take this data set and we'll pre-calculate the information that we need. So we need to create a new field called original area or O area or whatever, and calculate the value of area into that, and that will be our practice at doing something that needed to be done beforehand. So when you create script tools in the future, remember that's one of the first things that you do. After you figured out how you're going to tackle the problem, think about, is there anything that you can do beforehand? And sometimes that actually involves looking at the whole process, because sometimes, in math, right, A plus B plus C is the same as C plus B plus A. They're the same, right? You don't have to do, not all steps have to be done in the same order. So sometimes it does involve looking at the problem and seeing if there is a way that something could get done beforehand. Okay, but in this case, I don't know. I was going to say that's the only one I thought of that could be done beforehand. But if there's any others that you can think of, it's a pretty simple. What we're doing is fairly simple. All right. Now, why can't we do the intersect beforehand? So I'm going to add a field called. I'm going to make it a double. I'm going to call it O area, just for original area. Now, it actually doesn't even matter what this field is called, particularly if we're going to package this up as a tool, because the end user will never actually see this value. Okay. All right, so I'm going to create O area and calculate the O area into it. Now, I'm doing it without doing the toolbox version. I'm doing just the GUI. It doesn't really matter how you do it, especially if it's going to be something you do beforehand. So we could do it like this and just say original area is equal to shape area. All right, so I asked the question, why can't we do the intersect before? Well, one of the layers that we're going to intersect is the interactive layer, and that's going to change every time we do it. So we can't do that beforehand. Really, there's only a few steps. You can't do the dissolve because that's dependent on the intersect. So we've got our new column with the O area, and we've got our data. Okay. Okay. So the next thing that we want to do is start. What? Yeah. Go ahead.
What did you do in that field calculator? Exactly.
Oh, sorry. So when I right-clicked on this guy, it said field calculator. I just said shape underscore area is equal to O area. If you did it through the add field button, it would be similar, but it wouldn't. It would have exclamation points. What kind of error? You getting an error? Right click on this one. Say, O area. And say, fill calculator. That looks like it should work. I'll say okay. What type of what data type is O area? Is that a double? Properties? No, I guess that's the problem. It's not good at decimal places. So some people are getting errors because they forgot to make it a double. Right click on
That's what my problem was.
Right click. Properties. Yeah, such a short. So delete it and just recreate it. You can't edit it. Yeah. Just delete it, recreate it, make it a double, and then it should work. So the error that you're getting is these numbers have decimal places in them. And you're trying to store them in a field that doesn't allow decimal places. And so that's why it gives you an error. And you could convert this shape area to a. You could change this to Python and type in int. Right? What does the int function do?
Truncates the decimal.
Yeah, it truncates the decimal, forces it to be an integer, and then it would just store integer values in here, and that would probably be okay. I mean, we're talking about square meters, right? So if we're off by less than a square meter, that's like this much space, and we're talking about census block. It's not super important. I usually put a double, but I don't think it matters. I think all the floats will be big enough. It might not have as much precision if you put float. You might have to widen the column. But again, if you don't have the exact same numbers because you put a float on the left side of right side, it's a square meter, so it's not significant. All right, so at this point we could write up the code, or we could do the toolbox. Okay, but I talked about last week. I think it's a little bit easier to get the code working outside of ArcGIS, and then get the toolbox to work. The problem is here, we're going to be using, we're going to be doing some new things, but we'll still do it the normal way. Build the script first, and then we'll bring it into here. And we may have to change a few things in our script to get it to work right. Okay, but we don't have to change much. The first thing is, even if it's if I told you we wanted to be able to draw an interactive box, okay? So an interactive thing is called a feature set. And a feature set has all the same properties and aspects that a normal feature class has. So we can let's create a dummy feature class that's going to be that representation of the feature class, okay? So the dummy feature class has to have geometry, and it also has to have a schema, which means that it has to have fields. Now, I don't think we need to have a bunch of fields, but anyway. Anybody remember back from your days in 217 how to create a new feature class? We're gonna create a new feature class. It's gonna be a polygon. We're in ArcMap. That is a way to do it. That's the way I often do it. So I open up. I don't open up Catalog as a separate application. I just open up ArcCatalog here, and I go to where I want to put the thing. I'm going to keep it in the same folder. I'm going to upload this later just as a zip file, rather than. So the example will just be zipped all together, and you can unzip it and put it wherever you want. So I'm going to make it general so that it'll all go in the same place. So I've got my SPA lab. Where did I put that? I thought I had one. CTEMP SPA lab. I'm going to keep it in the same area. So right there, there it is. And then I'm going to put it inside this this one. And I'm just going to call this new feature class something like user polygon. It's just the user polygon that's gonna be stored. In ArcGIS, not every GIS system is like this, but ArcGIS is, and most of them are. We have to decide what kind of feature class it's going to be before we actually get very far. Okay? Because every feature class can only be one type of feature. So we have to decide whether it's going to be a polygon feature, a point feature, or a line feature. Unfortunately, if we want to let the user pick whether it's going to be a point, line, or polygon feature, we have to do something like make all three optional, and then just check to see which one got a value. It's really the only way to do it. But we're going to make it so that it's a polygon feature. Okay? So it'll be polygon feature. If you want to create a point feature, you could just create a little teeny point, and it would work. Okay, so we're going to create a polygon feature. Nothing else on here has to change. We don't want z values. We don't want m values. We don't need to put an alias here. So we hit next. All right. The next thing here is, this is actually important. If you don't select the right projection, it won't let you draw it on the other features that you have. Okay, it'll get all mixed up. So whatever, if you're eventually going to turn this into an interactive, you draw it type of thing, you need to make sure that the projection of whatever you're going to draw on is the same projection as your dummy data set that you're creating, that we're creating. So the best way to actually do that is under here, you hit import. Under this drop down, you choose import, and then you select the data set that already has the projection you want. In this case, the block group _HS. It's like Southeast Mississippi, except for the coast. I don't know That's what this, it's all the counties kind of, it's the Pine Belt without the coast. All right, so that's what that does. So now it's got that highlighted, whatever the projection was in. So now I can click next. So now this pretend data set will have the same projection. Usually this value is okay to leave as a default, but what this does is it says, I'm only going to store your XY coordinates out to 1,000th of a meter. It's probably sufficient, especially for what we're doing. But you could change that. You could change it to 1/10 of a meter or 1 meter if you wanted to. And then it'll round off all the coordinates that you interactively create to the nearest meter if we changed it. So anyway, it's probably fine. Except default resolution, that's good. If you had a very, like if you were for some reason going to put GIS data in of a site plan, then that's a reason why you might want to go out further. Okay, where you want it to be good within a 10,000th of a meter, which would still be pretty small. Okay, this one's fine to leave as a default. Okay, here, when we interactively create our polygon, the user could create multiple polygons if they wanted to. And there is the ability for the user to be able to specify the tabular information that goes with their interactively created polygons. And we're just going to create one polygon. But I'm letting you know that if you wanted to put additional data in here, typically there's maybe one or two others that you would want to put in there. You don't want to put in a bunch of information. These two have to be there. The object ID and the shape have to be there. But if you wanted to add an additional thing, like maybe you call it region, and then, actually, maybe let's just do that. So we've got a field called region, and we'll let that be text. So the user can input that if they want to. And let's give it a default value so that they don't have to put in the value without making an error. So the default value there can be just user area. That sounds good. Hopefully this doesn't mess up my carefully constructed scenario here. So that's the user area, and that's the region. This way, like the ultimate goal here is to calculate for a value how much is in a user polygon. So now we could enter two polygons at the same time. Compare. Is the population here any different than the population there or something? All right, so then we hit finish. So now we have our user polygon here. If you don't have it, you can just drag it over. Drag it over from here, our user poly, drag it over to the thing. Now to get this to work, we actually have to create a dummy user polygon right off the bat, just so that when we actually run this, we get an answer. If we didn't create a one beforehand, we wouldn't get an answer, because if we intersected this with this right now, what would happen? Yeah.
What is it?
If we intersected user polygon with block groups right now, we would get an empty feature class, because the intersection of an empty feature class and another feature class is nothing. An empty feature class. It's kind of like multiplying by 0 in a way. All right, so to do that, we just go to the editor and say start editing, and then draw a polygon. I'm going to draw a fairly small polygon. Like, you don't have to draw in the same place if you don't want to. Oops. I need to open up the editing windows, create features. And select under user polygon, I need to select it, and then just start drawing it. So there's the polygon that I drew.
How did you get the select thing again?
How did I start drawing it? Editor, start editing, and then I went under editor, editing windows, create feature. Create features.
Okay, and then it snaps to each polygon?
Then you make sure you select user polygon. And yeah, it does look like it's snapping. So if you don't want it to snap, because if that's an issue, go to editor and then go to snapping and then go to snapping toolbar and say options. No, not options. Where is it? Let's just turn off point snapping and we'll turn off end snapping and we'll turn off vertex snapping. I will turn off edge snapping, and now it won't try to snap to anything. But it doesn't really matter if you snap it or not for this example. We're just trying to draw a polygon
Okay.
on the map somewhere. It doesn't even matter where it is because eventually it's going to be interactive. And so if you say editor, stop editing, save edits, yes. Now if we open up the attribute table, see how we got an object ID, polygon, and for that region we got user area. That was the default value we assigned it. And that's all we need. We've got our fake area to deal with, our test area, I guess you could say. And now we can start building the tool. All right. So, in order for this to, I'm going to give the exact requirements here. So what we need to do is take this and we need to find out the value, the total value for any field. So we're going to give the user the opportunity to select a field. Not only that, we're going to allow them to pick multiple fields. So they can choose any field and it can be multiple fields. They choose a field, multiple fields, and we need to create a new field for each. I'm using computer words here. For each field that they select, we need to create a new field and have the adjusted population for each of the new fields. So we need to do an intersect, and then we need to do however many add fields there are. We haven't done a loop since we started using ArcPy, but we need to do a loop. Add a field for each one, and then calculate the value into the new field. We could actually do both of those. We don't have to write two loops, right? I don't see why that would matter. Create a new field, calculate its value, create another new field, calculate its value. And then we just do the dissolve at the end. Okay? But we also need to remember that when we do the dissolve, we need to summarize each of the new fields that we create. So pseudocode here for a second. We need a loop to create everything. And if you remember when we did the dissolve, we had to feed it a list of all the fields we're going to summarize by. So how could we build that list? Where would we build that list? We're going to have an empty list, and we're going to be building a list of all the fields that we created. Would we do that inside the loop or outside the loop?
Outside.
It's inside. How do we know how many fields to create? So that is one of the pieces that we'll have to figure out once we start dealing with the toolbox, right? So like I said, that's one of the new concepts that we're learning today. So right now, let's just set a variable equal to a list of fields. And we'll know each of those fields we'll have to do it for. Okay? And so we're gonna need to know that we need to get a list of fields later. But we'll set up in our code and have it. In fact, we can start doing that. Where's IDLE? So I'm going to start thinking about, and this problem is actually in this way. So there's some other complexities about the lab that's going to be your test, but in this looping part, it's actually a little more complex. So we're doing it together. All right. So
What do you mean exactly by the list of fields?
yeah.
Like, are they making multiple polygons, or is that?
No. Okay, so good question. So in this attribute table of the census, instead of calculating just the total population within that blue polygon, we want to let them, let's say, calculate the population in 2017 and the population in 2010 and the population of people under 5, all three of those fields. So the formula for calculating the amount is the same, where we take the new area divided by the old area times the value in the field. Okay? But we want to do that for multiple fields. We want the user to be able to select which field that they want to, or which fields, multiple fields. So basically, there'll be a list of fields like this. I'm pretty bad at coming up with variables, right? It's better than calling them thing. We'll call this just a field list, because I don't think there'll be another field list. Field list is going to be equal to, and then we're going to have some list of fields. So let's come up with, in our example, let's come up with the fields that we just want to test with. Okay, how about the population in 2010? So pop 2010, and let's just do 3. Let's do some of these other ones. Age under 5. Let's do that one right. Oh, age under 5, and
How about median?
we got median age. Well, median age won't work because this only works with totals. But that's we could recalculate the median age by doing all of the age groups, but that's a lot. So let's just do males or females, whatever you guys want. I want to. So I've got a list of population 2010, age under 5, males. Of course, I only really need to do one or the other because this minus this is going to, for the most part, give us a value. All right. So, all right. So that's the example of the list of fields. Okay.
So that is going to take place of the user input for now.
For now, yep. The user's going to, basically, what we haven't talked about yet is how to get from the user input a list of fields. But we will talk about that. Okay. So that's going to take the place of that. What are the other inputs that we need? Because let's set that up. Inputs to model. So what we need right now is we need the census data. Okay, we need the user poly. We need the distance, the buffer distance. because it said we're going to allow the user to buffer the, I'll just write buffer distance. So we need to allow the user to buffer the distance, and then we need the list of fields. I actually think we should put that up with, just for organizational purposes, we should probably put that up here with the census data, because it's going to come from that data set. Okay, was there any other, so the scenario is that we're just figuring out the amount of things inside, it's people in this case, but people in different categories, inside that polygon. Is there any other data set that we need? Eventually, we'll need to let the user specify where they're going to save everything, right? So the final thing is the output location. But I can't think of any other thing that we need. All right, so let's get a reference. Right now, we'll just hard code in the census data. In fact, we'll keep that hard coded. That'll always be the same. And the user poly data will also, for now, be hard coded. But we'll talk about how to make that into a feature set later on. All right. So, and then I'm going to copy this up or put it up here. So, the census data, where are we going to get that? That's we can just right-click on this guy and get the path to the census data under source. And call this, I'll just call it C data, because I'm horrible at spelling census anyway. R, I didn't just say R because I wanted to talk like a pirate. We got the R meaning don't ignore special characters. And we need to do the same thing for this user poly. And it's going to be in the same directory because that's where I put it. But we called it user poly. User poly. Okay. So now we have our user polygon, block group, buffer distance. Now the user is going to be able to select this. And so let's just type in a number, and remember that it's going to be in meters. So I'll call this buff dist, and I'll set it to be 1,000. What's that? Oh, you're right. Thank you. poly. All right, so now I think I have all the inputs that we want to do. And let's just set the output up. For now, we'll call this summarized. I'll just call it sum area. Okay. So it's going to work its data here and come up with a sum area. We could change this so that it's a string, because we're going to need to change it to a string anyway. And remember, we can always say set parameter as text or get parameter as text later, so that it'll be a string.
Do we need to call it something other than uPoly? Output poly or something?
Output poly. I called it sum area.
No, it's part
Oh,
after that you call
I messed
it
up
poly.
again. You're right. Thank you. Okay, so now we need to code it up. So wiring this up or coding it up just means that we have to first do the intersect, then we have to do our loop through each field, and then inside of that we need to add a new field to hold new values, calculate calculate new value as new area divided by old area times field. So that's the formula in all cases. This will turn into a proportion, multiply that by the field value.
I have trouble with that on last week's lab.
You did have trouble making it work?
Yes.
Okay, well, we can talk about that. Just forward me your code and tell me what the issue is. I'm not, this will matter if you don't correct it everywhere, but I forgot the old I before E except after C rule, I guess. Okay, calculate the new values. I think that's it. And then outside the loop, we need to dissolve. Oh, I was going to say build field list for dissolve. Now, notice that we're working on a geodatabase. I like working on a geodatabase when I'm writing scripts. One of the reasons is that shapefile fields are really unpredictable as to what the fields actually get named. Because if you name a field something, it will decide, oh, that's too long, and it'll just truncate it for you. And then your script will end up failing later on. So oftentimes, if I'm going to be scripting something, I put all my data into geodatabases. This is good practice anyway, because a lot of times when you go to work in an actual place, more and more often we're dealing with data in geodatabases, whether or not it's a file geodatabase or an enterprise geodatabase. The disadvantage is that you can't bring it up in Excel quickly because there's no DBF. But you can always export the things that you don't want, that you want to look at in Excel later, and then bring them up in Excel once you've exported them as a shapefile. So anyway, okay. So, oh, I forgot the very first step here because I did say that we have to do buffer. Okay. So let's think about what needs to go on here. We're going to buffer. What layer are we buffering? uPoly. Good. So I'm going to do the thing where I find buffer. I know that buffer is under proximity, under analysis tools, proximity. Buffer is right here. So I'm going to go to the help in that way. I got in the habit of doing this back, a long time ago. Internet connections weren't always reliable. Most of this stuff is on the internet, but I'm just going to do it right there. There's a help. I'm going to put this in here. So buffer analysis. I'm going to buffer the uPoly.
Copy and select.
I just copied this line right here. No, the buffer analysis. We're buffering. So we could go back up here and look at what the inputs and the outputs are. The input is, the first parameter is the input feature class. The second parameter is the roads buffer. The output feature class, the output feature class is the second parameter. The third parameter is the line side, the inline tie, the third parameter is the buffer distance. Everything else is optional and we don't even need it. So I'm going to go over here and delete everything else. I'm going to change this to buff dist. Now this is, I don't know if I brought this up. Have we run buffer tool yet as a script, in a script? One thing to remember is, if you actually read this buffer distance or field, is that you can give it a raw number, like 1,000, but you can technically give it a number like 1,000 space meters or 1 kilometer. But we're just going to give it the buffer distance in meters. If you don't specify a unit, it assumes that the unit is the unit that the projected coordinate system is in. So in our case, that's meters. So right here, if the linear units are specified and are entered as unknown, the linear unit of the input features is spatial reference is used. Even if your spatial reference says unknown, it's still going to, it still has an actual coordinate system attached to it, whether or not it knows what it is or not. Okay, so the only question here is this one. This is the input, which is the polygon. This is the output, where we need to save it somewhere, and this is the buff distance. I'm going to suggest again that we use in-memory. And so one thing I'm going to do is create another variable up here called buff output, and just say in_memory. I like using in-memory a lot for data sets that are vector data sets that are temporary. So I'm going to call this in-memory underscore, I'll just call it buff out again. And then I have that. So now it's going to create this buffer. I'm not going to be able to see it. That's the disadvantage of in-memory. It's going to create it. It's going to save it here, and it's going to do a buffer distance of 1,000. Okay. Now we're going to do the intersect. I'm going to do the same thing. I know the intersect is under overlay, intersect. I'm going to hit tool help. I'm going to go copy the intersect analysis right there. And again, I'm pretty sure that everything except for the first two features, the first two inputs, are optional. I can go back up here to check, and yes, it's all optional except for the first two stuff. So I'm going to do that right there. Delete everything else besides the first two inputs. You wouldn't use those much. So we've got the input features. What are the input features going to be for our intersect? We're going to intersect these two layers, and it's going to give us the intersected, in other words, only the areas that are common between the two layers. Yep, we need, nope, not the user poly. What's that? The census data, yeah. And what's the other layer that needs to be input? Why do we do the buffer if we're not going to use it? What's that? Yeah, we're going to use the buff output. All right, now, I need to put a little guy like this. So you can see from the help right here, if we go to the tool help, you can see that it wants a list of the input feature classes. So we're going to input a list here. Now the output, where it's going to save it, a couple of people actually came to me with the same problem because they used in-memory as the output here, which should be fine. However, if you use in-memory, it doesn't automatically create an area field. It also does that with a shapefile. Shapefiles don't automatically create area fields either. So the problem is you won't get an automatically created area field. Now there is a tool called Calculate Areas that you could run. So you could run in, you could use the in-memory, do the intersect, then run the Calculate Areas field. But that's not the way I told the people that asked me the question. I said, just change it to a geodatabase. So that this output is a geodatabase, it automatically creates that. I'll show you what I mean here though. If we go back over here, I actually don't know where this one is. Calculate. Maybe this has been a long time since it ran. Actually, let's do it this way. So, because this will be interesting, and we might as well. I'm gonna go It's the calculate field that actually has the help. There it is. So calculate field. Alternatively, if you don't want to search like I just did, you can go to in here, and you can find the tool. The tool is actually under Data Management Tools, Fields, and then Calculate Field. There is a decalculate area. That's in the GUI. Okay. So there's a Calculate Field, and you hit Tool Help, and you'll get to where I'm talking about. All right. In the help, if you read through the help, there is a way to calculate area. Okay, it's !shape.length, and then you optionally can write @ and type in kilometers ! You don't need to type this part if you want to just get it in the same units. So it's shape.length, you put an exclamation point there. So let's use this, and that way we'll still be able to use in memory. Okay? It'll be it'll make it so that our formula is slightly longer, but only slightly so, okay? Let's show you where that goes. Okay. So we've got our code here. So we still need to do our intersect. I'm going to call this int output equals in underscore memory slash int out. Okay. So that's going to, what's that?
Slow down. Can you just slow down
Yeah.
just a bit?
Yeah, I'll stop there for a second.
Which one did you copy back on the tool help? That was where I derailed.
The intersect?
Yeah, the last one. Then we try and copy the. We're trying to add the geometry.
Oh. No, I just pointed that out. That's going to be copied down when we actually try to calculate the new value.
Oh, okay. That's.
Yep. That's coming. So I was trying. I'm just presenting something differently than I did to present it to some people that asked about if I use in memory, and most people didn't even use in memory, but a few people were using in memory. But if we use in memory, it does not create that shape underscore area field. It doesn't create it
Right.
automatically.
And that was something I ran into as well.
Okay. So if you don't create that automatically, you need to be able to get it out some way. We're going to show you how you could do that down here.
Okay, perfect.
A few people, the way I answered the question was to tell them to just change this to a just make another location that's in your geodatabase and call it intersect output, and then it'll create it automatically. And that was okay back then, but this is a way to do it so you can do it in memory, so it'll actually operate faster, and it'll work. Okay. So we got our in memory. All right.
Can I ask a question?
Yeah. Go ahead.
How do you know if you're dealing with a file that's going to be too big to put into memory?
It's tough. I mean, you don't know exactly. But now there is you could probably figure out the point. You could create a few and see on average how big they are, just running it. And here I know that they're all going to be big enough. I mean, I don't know how many, well, we know it's not going to be any bigger than this data set. We can look at how big this data set is on disk. It doesn't say that anymore here. Does it say that in here? If we convert it to a shapefile, it'll tell us how big it is on disk. We can see how big it was on disk. And then once you saw how big it was with rasters, it'll tell you how big it is on disk, whether or not it's in a database or not. So that's plus with rasters, it's really easy to figure out. But in any case,
The
if
other reason I was asking is that ArcMap itself, it consumes so much of your processing power. Are you going to just crash the system if you put too large of
yes, you will. There is a point where you'll crash the system, or it will become very, very slow. So the operating system, what it will do is if your available free memory is smaller than the size of the data set that you're asking it to shove into your free memory, it actually will it'll take part of your hard disk and use that as memory. And once it does that, your system becomes very, very slow because it's, first of all, your hard disk is slower than your memory, but it's starting to have to read to that slower piece going through two different, like going one way and then going another. So it's doing two different operations. It's basically doubling the amount of processing that it would do. So you probably notice that it goes a lot slower, but there's no way this gets even close, even on the computers you guys are using. But yeah, if Intersect is a fairly comprehensive, a fairly big thing, but this is actually only about how big it is after it's done it. Okay, so it's big enough. It's going to be it's not going to be too big. But the way you could figure out how big it's going to be is experiment, save it as a shapefile, look at how big it is on disk. And this one's probably going to be a couple hundred kilobytes on disk. Okay. So it's related to the number of vertices. So each vertice will take a lot of space. Now, the amount of records in the table does have a little bit of impact, but not as much. So let's say you had 2,000 records in your table. Each row is going to be, so if there's a float, that takes up a certain amount of space. If there's a double, it takes up a certain amount of space. But what data sets have more than, even, there are data sets that do, but anyway, you can figure it out, but the best way is to just experiment, I found. All right.
Dr. Rick,
Yeah.
did you take a moment to just walk through this code, what we've got so far? 'Cause I'm not tracking what this is supposed to be doing. I know on paper and on GitHub what we're trying to do, but I'm not seeing it in this code.
Okay, so this is basically the same problem that we presented 2 weeks ago. It's the problem of trying to take an area and disaggregate it and say if part of an area is inside of another area, we're going to assign part of that population from that area to the new polygon, which is smaller. So to do that, what we're doing here is getting the inputs, first of all, that we need to run the model. And then
What's from ArcMap?
yeah, they will become the inputs from ArcMap. Right now we're just setting up some default values. This one here is always going to be the same, but these three are going to be user-specified inputs. The user is going to be able to specify their own fields. The user's going to be able to specify their own polygon, and they're going to be able to specify the buffer distance. And then what's going to happen is, once they specify those things and run the tool, we're going to find out how many people live in that area. We're going to find out how many people under 5 live in that area, and we're going to find out how many males live in that area. So that's the goal. And then the first thing that we do is buffer it to make the area big area. And then we're going to intersect. We're going to take the intersect is the areas that are the same between these two data sets. So we're going to cut one of the data sets out with the other data set, basically, is one way you could say that. Now actually, now that I think about it down here, if we're not concerned with any of the attributes in the intersect analysis, we could do a clip. There's really wouldn't have any difference here. But if we are going to let the user, like let's say, select 3 different polygons and name each polygon a different region, then we will have to dissolve on that. But so let's just leave it as an intersect to make that a possibility. Not that we'll even go through that. All right. So now the next step is to loop through each field, each of these fields, and add a new field to hold the new value, calculate the new value into that new field, and then build a list of those new fields that we've created so that later when we go into dissolve, we can have a list of fields to summarize on. Okay. All right. I think that it would be helpful actually to look at the dissolve first, just to look at what it does, just to refresh. Okay. So the inputs for a dissolve are the input features, which are going to just be after we've intersected, we're going to create these new fields. So the input features are going to be the intersected data. Okay. The output feature class is going to be kind of like the final result of our study. It'll be the end. Okay, so we do actually want to save that, not in memory, because we want people to see it. All right, the dissolved fields are going to be the fields that we remove the common boundaries of. Okay, so those will be just the regions in the original user polygon data set. Okay? Now, when I first set the scenario up, I said we were just going to create one polygon. So notice how this is optional. We could just leave it blank. If we don't care about different regions, the user selecting different regions, we can leave this blank, and it'll just say the total amount of people in that circle, or in that polygon that you drew. Okay? So this would be a list. That would be a list. If we could look at the help, it'll tell us it's a list. I'll show you. This is a list of fields. So this is a dissolve field list. Okay. We could, like let's say we wanted to let the user find out how many people are in county A versus county B and inside the polygon. Then we could select both the user polygon field and the county field. But we're not going to complicate that. We're just going to leave that blank. Okay, the statistics field is actually a list of lists. And this is the list that we need. This right here is the list that we need to feed the dissolve when we do it. Okay? So look at the tool help. We need to feed it a list of lists. And each list is just going to contain a field name and a statistic type. Field name, statistic type, field name, statistic type. And the statistic type is going to be what? We said the total, so which one of those? Sum, yes. So we need the new field that we create and sum. as a list. And then we need to put that into a list and do the second new field and sum. Put that in the same list. The third new field and the sum. Put that in the list. So that we create a list of these lists. These small lists. Each list only has 2 items in it, each small list. And the big list contains a list of each of those, a Python list. Okay. All right, so that's the dissolve part. That's going to go down here. I'm going to copy it over right now. Copy this one. Now the default is actually multi-part. And we can decide what we want. I would say that typically we want to say that multi-part is allowed. In other words, if they share the same values, even if they're not connected, they can be the same polygon. Now, in our scenario where we're only letting them draw one polygon, and we're not going to specify a dissolve field, it really doesn't matter. These are both the same. They're equivalent. So I'm going to put this in here so we can be thinking about it. Okay. So for our dissolve fields, we're not going to feed it anything, but we do need to put our list, let's come up with a variable name, list of summary. I'll just go ahead and be verbose this time. So list of summary fields. This is our list of summary fields. It's going to go right here. This is our dissolve field. If we want to get fancy later, you could change that to be the user regions one. Our output feature class, and this is going to be our temp layer, which is going to be this one. So let's go ahead and copy that down. That's going to be the output of the intersect. So our output feature class is, we call it sArea. So let's rename that. So the only variable we really need to collect or create is this variable right here, this list of summary fields. Once we create that list of summary fields, we'll be done. So we need to do that somewhere in this list, and then actually make sure that list of summary fields contains the data that we want. Okay. So really, we need to run two processes, add field and calculate field, and then we need to build this field list slowly. So one thing that we could do is remember that outside the loop to create our empty list. Anybody how do we add items to a list? Do you remember the code word for that? Append, right. So somewhere in here we need, well, first of all, let's out the for loop. For, what are we going to say? We could do for field in field list. So each time through the loop, what's field going to be the first time through the loop? What value is field going to have? Yep, it's going to be pop 2010. So somebody said 0, and that's fine. In like a more basic computer programming language, that might happen where we said for I equals 0 to 10, I would be 0 the first time through the loop, 1 the second time through the loop. But Python allows us to abstract that, and so we don't have to actually reference field list in the loop. We can just say for field in field list. So if we have a sequence, field is a sequence, we could just say for item in the sequence, and then each time through the loop, we don't have to ask what population 2010, we don't have to get that value. That value is already stored in field. So the first time through the loop, field would be pop 2010. Second time through the loop, it's going to be age under 5. Third time through the loop, it's going to be males. Okay. Now at the end of our loop is where we need to say list of summary fields dot append, and then we need to feed it the new field that we created. All right. So the process here is that we need to add this new field. So we need to find a name for that new field, because the old field name is Pop 2010. We can't use that name. It's going to give us an error if we try to add a field called Pop 2010. Okay? So what could we do so that we could still know kind of what it meant? What's that? We could write like adjusted. So how would we do that in code? I want to have a variable called new field. It's going to be the new field. Technically, it's a new field name equals. Somebody suggest what I should put there in order to get Pop 2010 underscore ADJ for adjusted. The first time through the loop. The second time through the loop, I want it to be age under 5 underscore ADJ. Field, right? And then you said, what was that part?
I don't remember how much that works.
Okay. Well, we just want to append this text on the end, is what I'm trying to say. Yeah. But we're not to the part of actually you were saying you don't remember how to do the formula.
Oh, maybe there was something like
I'm talking about the field name here. Yeah. So, yes, you're saying I don't remember how to do that formula. The formula is just this one right here. Okay. So now, once we have the new field name, we need to actually add that field into the table. Which table do we need to add it to? The user polygon table. That was way back up here. The int output table, right. That's where we need to put it. We could have actually added it to any of the tables that get intersected. So we could have added it to there, but then we'd have to do a loop there and then a loop there. So it makes more sense to just add it into this table where we're already working on. So the int output is I think the best answer. At this point, that's where we need to put it. If we put another loop up here, we could have done it, but then we'd have 2 loops. All right, so fields, add field, and this one's pretty straightforward. Just going to pull down. All we need is this information. What data type should we make this field? It would be, I can tell you're thinking about it, and that's good. Audrey was saying that that we should make the data type be the same as the original field, and I think that's a really good answer, because whatever data type this field was in, this field should be in the same data type. Okay, and I think that would be good. That would involve a little bit more programming. Have we covered how we would get that information out of there? I don't know that we covered it explicitly. We could do it, but we haven't really gone down that path. But I'll tell you that. So we can arcpy field type. So we can ask it to list a bunch of fields, and then it'll give us an object of fields, and we can ask it what type each field is. But we don't really have a hold of the field object, we only have a hold of its name. So we'd have to write a function, and we could do it. We'd have to write a function that would go through each field, find the field that matched our field, and ask it what type it was, and return that data type out. Okay? So maybe that's something for a demonstration on another day. I think that what we're going to do now is we're just going to assume that the user picks an integer field. So all these are population counts, so they're always going to be integers, and we'll just leave it at that. You could argue that maybe we should just make it a double, because a double could hold any type of number, whether or not it was an integer or not. So that would be a good one. Actually, let's do that. Let's make it a double, because that will hold any type of numerical value. Now we're still going to get an error if the user selected a field that was non-numeric, that was a text field. We're still going to get an error, but we could put an if statement in here and try to figure out. We could put a try statement. If it fails, we could say your fields probably aren't numeric, something like that. Okay, so double. All right, the input features and then the field name. What's going to be? What are those two? Well, actually, I already asked the question of what that's going to be, right? That was going to be the end output. So let's take that. What about this field name? What's that going to be? Yes, it's going to be the new field. So it's going to have a value. It's going to be, the name of the field is going to be the old field plus ADJ on the end. Stands for adjusted. All right. Now, we need to give it a, we need to calculate that value. So this is the value we need to calculate. This new area, though, is now a question mark because there is no shape underscore area field. There's no shape underscore area field. There is an O area field, and the field value is just going to be the field value for field. So we need to construct a expression, and it's going to be kind of a long expression. Not hugely long, but here is the calculate that field help. So I'm just going to copy the calculate field and put it right here. Yep, okay. So the end features for this are going to be the same. The field name 2 is going to be the field that's going to receive the value. Which one's that? The new field, yep. Okay. Now this shape.centroid is actually kind of giving us a head start on what we need to do. But we're not allowed. They just formatted it so you can read it better. We're not allowed to actually have these spaces here. We want this to be shape.area. If we go back and read the help up here, shape.length or geometry, shape.area. I don't know if it's case sensitive or not, but I'm going to do what the help says. So I'm going to make this all lowercase. So that'll make the shape area, and I'm also going to, what's the default? Is it Python? No, the default is VB. I'm going to make it just regular Python, though. I think it works best in Python. Make this bigger. All right. So now what we would do is we're going to take the new area, and it's going to become the value of field. That's not exactly what we want, is it? We want this whole thing. So new area is shape.area. So we actually want to divide that by the old area. What's the name of that field? I call it O area. Let's see if that's what make sure that's what it's called. I'm just gonna look real quick. And remember, we just decided to make this a permanent fixture. What do I need to put, why do I need these little exclamation points?
Python field name?
Yes, that's the way you delineate a field name in Python. So, what's kind of cool is there's this special way to delineate a object inside of a field. So you can get the area of a shape by using those little exclamation points. Okay, we're going to put this in parentheses, and then we're going to multiply that by what? The old field, right? Okay, now, is that right? Take it out of the quotations. So is this right? It's getting closer, but it's not quite right. We still need exclamation points around the outside of it. Around the outside of the word field. Whatever goes in field. How do we get those exclamation points around the outside of it?
We have to literally go in and like plug.
Yep. So I'm going to leave this up here for a second because that might be, but that,
We used that,
yeah,
you did the format thing last week, could we use that, where we
You
did
could.
curly braces?
yep, exactly. So that's an option. I'll just put that in, I'll just call this F calc equals curly bracket 0 curly bracket. So that's an equivalent statement. That should work.
And then you'll just use F-calc below in the expression,
Yes.
location?
Right. I'll replace this whole thing. I'm just going to test to make sure that I'm remembering things right. So I'm going to bring up, because this is probably the better way to do it. I'm going to say field equals pop. Doesn't really matter what that is. And then, oops. Yep, that would work. So then you'd replace this. So that'll work.
Yeah, that was what stumped me on the last week.
And you could just put this in there too.
Where?
You could put this whole thing right there instead of writing FCalc.
Yes.
I'm going to go ahead and save this. I'm going to save this. I'm going to save this into the same folder I've been working in, which in my case is C temp SPA lab, and then I'm going to call this example 1.py. All right. Now we're really, really close. We do need to append it with the new field, but technically it needs to be a list of lists. So we need to feed it a list instead of just feeding it those values. So what else needs to be in there? Like that. That's all it needs to be. So now it's going to feed. I'm going to print this just so that we can see what it looks like. Okay.
Can you pause for just a second to
Yep.
let us get caught up?
I will pause. Is was gonna see if there's a way I could put the whole thing on one page, but I think there's too much up top, so I'll just go like, could probably pull that up. I don't know if that helps much though. I was thinking about just getting rid of these comments now, but maybe those will be helpful later.
Can you explain that, the AdCal statement with that format?
This one?
Yeah, I don't remember.
Yeah, so you can build a string by concatenating strings. So the way I typed it at first was to concatenate a string, but there's a special function that you can apply to any string that will take these values and replace them with these special characters. So if you have multiple values to feed it, like I could say another value, and then that would be 1. So what it'll do is, for each of these values, it will replace the squiggly bracketed values in there with the value that's in here. So it's a cleaner way to create text without having to concatenate text using the plus sign. The other thing is that you can feed it values that aren't even strings, and it'll actually do the conversion of the string for you. So you don't have to type in str. It's an alternative if you want to use it. The book does cover it, or you could just search for format. But it's a different way to create a big string and throw things dynamically into the middle of the string. All right. So at this point, I'm going to go ahead and run this and see if it works. I will switch immediately back to it, though, so you guys can continue if you want. Oh, I need to import ArcPy, or it won't work. If that was the only problem, that would be awesome. I should probably put some print statements in there to make sure that it's working. But it looks like it's doing something. What's that?
There's a lot to do without any debugging.
Are you gonna post that example, Dr. Abraham? I probably mistyped trying to keep up.
Yep, I will post it all. Okay, so let's look at the result and see what it looks like. So here is my sum area. Notice how it's been buffered out beyond the original. And if I open up sum area, I do in fact see these additional, the sum of the adjusted population, the sum of those under 5, the sum of the males in that area. So it's worked. That's great. We got that. All right. So I'm at the point where I've got it to work, but a lot of you might not have all the code exactly right. So you can look through it, or I could just post this example. Now, if you're getting something like such and such data does not exist, then that's not a problem. Well, it means that your paths aren't right. Okay, up here. But that's not necessarily a problem with your code not working. You don't have to have any of this the same as me, but the rest of it should. Do you want to just take like a 10-minute break right now, and I'll upload all this? Okay. And then you'll have it. And then we could talk about making it into a toolbox. Actually, let's make it a 15-minute break. That way, if you want to download it, make sure that it works for you. Then we'll talk about making it into a toolbox. Okay, so I've been saving this in a different location because I want to do that. C10. I'm going to go ahead and